This video is to help with the quiz on chapter 3, which would be kinematics in 2 dimensions. So I'm going to share my screen really quick, just so we can take a look at the questions. And so this first one has a lot of backstory, but it's true. So I think it's worth taking a look at some of the technology that's happening in our area. But the basic idea is that it's a relative velocity question. So we're going to take a look at a displacement vector that goes from Burlington to Mass General. And so we have a distance and a heading, and then this aircraft has to fly this distance in exactly 90 minutes. But there is some wind. So the pilot, AKA you, has to figure out how to deal with that. So let's go back and take a look then. So in this diagram, we're going from UVM to Mass General, and there's a distance and there's an angle. So based on that, we can find out how much velocity is needed in both X directions or east and Y direction or south, because the displacement velocity divided by, this displacement vector divided by the velocity vector has to equal 90 minutes. And of course, you probably want to change 90 minutes into seconds. So once we've figured out the time, then we'll know exactly VD stands for velocity along the displacement vector. And so once we know that what this time is, then we can solve for what the velocity vector has to be. So the velocity vector has to be equal to the displacement vector divided by time. And so once we get that, we can break this up into its X and Y components and place those right here. Now the wind velocity, that's totally up to you. It would make sense that you either pick something that's along X and no Y component, or something that's along Y but no X component. And then by subtracting, we can figure out what the components of the velocity need to be for the aircraft. And then if you know the X and Y components, we can recombine those into magnitude and direction. And that will take care of that problem. And question number two as well. Now for number 3, I'll share a screen again really quickly. Yeah, number 2 is just vector diagrams of the problem from above. Now the give and go, we have a defender who's 10 yards away, 30 feet, and 6 feet tall, and we're trying to pass to a player who can run at 14 miles an hour. All right, so let's stop sharing and take a look at a diagram. So here we go. We've got somebody who's going to kick a ball by giving it an initial velocity, which will have some speed and some angle. But it's better off to start off by thinking about the X and Y components, of course. So we convert 14 miles an hour to meters per second. And then what we want to do is think about, okay, we're going to kick this ball and we want the ball to meet up with our runner right here. So when we give it an X velocity, then that X velocity, this is actually a pretty easy way of thinking about it. If the X velocity is the same as the 14 miles an hour, then they're always going to be in sync. So now all you have to do is give it a Y velocity high enough so that in the time it takes to go from here to wherever our runner catches it, that its maximum height at half the total time of flight clears the other player's head. So one more time. We convert 14 miles an hour to meters per second. The easiest way to do that is just to make that the X velocity right here. And that way the ball and the runner are always going to be in sync. And then we need to give the ball enough Y velocity so that it goes over the player's head. Okay. So that simply means that we just have to give it enough Y velocity. So when it's at this time, right? So taking the runner's velocity, we know how much time it takes for them to be even with our 6 foot tall player that's 30 feet away. if we know how much time it takes for our runner to get there, that's actually the same time the ball's going to be there. And so then with that time, we want to make sure it has enough y velocity to go up and over the 6 feet. So anyway, those are a couple of hints, and I hope it helps.